Hello everyone. Today I'm excited to show you Medical Vision app, a powerful desktop application we developed for medical image analysis, especially designed for CT scan processing. This project integrates computer vision techniques, deep learning, and mathematical morphology to provide professional tools for anatomical segmentation and quantitative analysis of Deacon medical images. Let's dive into what this application can do.
Loading and visualization. The first feature is the ability to load and visualize complete DCOM datasets. The app uses ITKey, the Insight Segmentation and Registration Toolkit, to natively read medical DCOM files. You can navigate through multiple slices using this intuitive slider, and the file list shows all available images in the dataset.
Image preprocessing. One of the most important features is the preprocessing pipeline. Medical images often contain noise, especially from low-dose CT scans, so we need to clean them up. The app includes DNCNM, deep learning model for advanced denoising. This neural network was especially trained for image denoising and can run either through a Flask server or locally using an ONNX model. Besides DNCNM, you can apply classical filters, Gaussian filter for smoothing, median filter for salt and pepper noise, bilateral filter that preserves edges. And the contrast enhancement, we have histogram equalization and claje. Contrast-limited adaptive histogram equalization, which is particularly effective for medical images. The system applies filters in the optimal order. First noise reduction, then contrast enhancement. After preprocessing, you can see the PSNR and SNR metrics to evaluate image quality.
Anatomical segmentation. Now comes the core functionality, automatic anatomical segmentation. The app can detect three main structures in chest CT scans. First, log segmentation. The algorithm uses adaptive thresholding based on Hounsfield units, which are the standard measurement units in CT imaging. Log tissue typically runs from minus 1024 to minus 400, corresponding to R file spaces. The system applies intelligent filtering based in anatomical position and the area to eliminate small artifacts and ensure we are only detecting actual null tissue. Second, bone segmentation. This is more complex because it needs to detect multiple bone structures. The algorithm includes a specialized sternum closing technique using mathematical morphology, and it filters out noise in the spinal column region. Bone detection use range on 400 to 3071. Third, aorta segmentation, which detects the main blood vessel. This works best with contrast enhanced CT scans and use the range of 120 to 300. The algorithm performs connected component analysis and filters by area and anatomical position. A key feature here is that you can choose the segment either the original image or the preprocessed version by checking this box. The system automatically adapts the threshold based on the image type.
Morphological operations. After segmentation, you might want to refine the mask using morphological operations. The app implements 7 fundamental operations: erosion, dilatation, opening, closing, morphological gradient, top hat, and black hat. You can configure the kernel size from 1 to 21 pixels and the number of iterations from 1 to 10. Also, you can apply erosion operation. And there's also this dedicated button for filling holes using a fluid fill algorithm, which is perfect for closing internal cavities in segment organs.
The visualization module lets you see all your segmented regions overlay on the original image. You can enable or disable each region independently and adjust the overlay opacity to see the underlying anatomy clearly. Now, the metric dashboard. This is where you get quantitative analysis. The system automatically calculates RN pixels for each segmented structure, mean density in Hounsfield units, signal to noise ratio per region, PSNR compared to the original if you apply preprocessing. And here's a powerful feature for validation. You can load the ground floor mask, which is manually segmented reference image. The system calculates the intersection over union EOU metric, which measures the accuracy of the automatic segmentation. It opens with this comparison window with three panels: automatic segmentation in blue, growth through in green, and difference highlighted. White for matches, red for false positives, and yellow for false negatives. And this is an image for a qualitative analysis of the regions of interest provided by a doctor.
You can export all your results with a single click. The export function saves all processing stages as PNG files. Everything is automatically named with the slice number and description, making it easy to organize your results for documentation or further analysis.
For a technical perspective, the app is built with C++17 for the core processing logic, Qt6 for the graphical interface, OpenCV4 for image processing and morphology, ITK6 for decom handling, and Python with flags for the DNCNN interface server. The entire project is open source and available in GitHub.